Hi, my name is Pardis Emami-Naeini, and I'm an assistant professor of computer science, public policy, and electrical engineering at Duke University. Today, I'm going to talk about a series of research that I've been doing on the transparency of smart home devices. The title of my talk is Designing an Informative and Usable Security and Privacy Label for IoT Devices, and IoT stands for Internet of Things or Smart Devices. Okay, so let me start by talking about toilets. Not regular ones, but the smart ones. We have various expensive smart toilets on the market enabled with Amazon Alexa that could light up, or even better, flush for you with your voice command. We are also going to have a much smarter one that is equipped with several sensors, including cameras that could identify you and collect your health related information. This technology could be very useful in detecting health issues, but it could also pose a huge risk to users' privacy, especially if they're not aware of the device's security and data practices. Just imagine a scenario where your inferred diagnosis is being shared with your employer or insurance company without your knowledge and without your consent. So, people are increasingly purchasing smart devices. However, despite the surge in purchasing them, consumers are still concerned about the privacy and security of the devices they purchase. But the question really is, how much can they realistically do at the time of purchase to better protect themselves, to make better decisions? Many of us have the experience of purchasing a smart device for ourselves or others. Now, I want you to imagine the time when you were in the physical store or search online for the smart device to buy. You probably saw the information on the price of the device or its technical specification, for example, its size or internet connectivity. But do you remember seeing any information about the security or privacy practices of the smart device at the time of purchase? The answer is probably no, because usually this information is nowhere to be found. When purchasing a smart device online or in a store, consumers are not able to make an informed purchase decision, as the information on the security and privacy practices of smart devices are not readily available to them. So, one way to potentially mitigate this information asymmetry gap between the consumers of devices and device manufacturers is to make this information, security and privacy information, available and usable at the point of sale. And this usability is an important aspect, which I will get back to. But you may say that, well, we have privacy policies, but no one reads privacy policy. So privacy policy is not the solution because it's not usable. So to this end, I took a 6-year journey to design a usable and informative security and privacy nutrition label for smart home devices. And following our strong empirical evidence that the US consumers are increasingly interested in having such labels for their internet connected technologies, we actually recently presented this research at the White House Security Summit. And according to the recent White House executive order, we should expect seeing this or a simpler version of this label in the market, in the US market of smart home devices over the next few months. So, very soon. But today I'm going to talk about the journey of designing such a label. and the projects that basically led us to design a label. So designing a security and privacy nutrition label from a concept to a usable label that conveys the most critical security and privacy information is basic that took some years, and we conducted several projects together. And today I'm going to very briefly go over each component of this human-centric and consumer-centric process. Okay, starting from the beginning, the first project that I conducted was to understand whether consumers even want to have such a label at a time of purchase, even if they care about having such security and privacy label at the point of sale. That's the first component. In this study, I wanted to show consumers a reasonable prototype of the label that includes some important security and privacy information. Basically, I wanted to see if they even want to have such a label. So I wanted to design a prototype label. To design this prototype, I conducted an extensive literature review and went through more than 70 IoT security and privacy references from academia, governmental organizations, both in the US, including NIST, and international ones such as DCMS in the UK and ENISA, nonprofits such as Consumer Reports, as well as guidelines from various companies, including AT&T, Intel, Microsoft, and Symantec. Based on these documents, based on these survey documents, I then designed the first prototype of my label, of my smart device label, as shown on this slide. So this label has three sections: general information, privacy information, and security information. Throughout this talk, you will see how we revised this label to get to the final design of the label. But that was kind of the prototype label, that the first version of the label. I then interviewed smart device consumers who captured their feedback on this label. Almost all consumers reported that they would like to know about the privacy and security of smart devices before making device purchases. From this study, I also found that it's currently very difficult for consumers of smart devices to find information about the privacy and security behavior of the devices at a time of purchase, and that they are very excited about the idea of having such labels at a point of sale. One of our participants said, as opposed to those long policy documents I usually need to read, I think this is a very efficient way, and I cannot think of a better way than this. Several pieces of legislation have been proposed, some very recently in the US and in a few countries outside of the US, including UK, Singapore, and Finland, which would require IoT labels. Some even mention a few factors that should be included on these labels, but they don't contain too many details about how these labels should look like. And as you can see from the headlines, almost all of these proposals are primarily focused on security attributes without much attention to privacy practices. So my next goal in this journey was to identify the information that should be included on an IoT privacy and security label to make it both usable and informative, which is the second project that I'm now going to talk about. To capture a holistic view of the desired content of the label, I interviewed and surveyed a diverse and gender-balanced sample of security and privacy experts from industry, academia, government, and NGOs, non-governmental organizations. The recruited experts had to satisfy at least one of the following criteria: being a faculty member in the field of privacy and security, having at least 10 years of research or practice in privacy, security, or policy, being an author of known books in the field of privacy and security, having active involvement in cybersecurity standardization, or leading a product team in industry, the IoT product team in industry. The experts acknowledge the value of the label in informing consumers' purchase behavior. One of our experts said, What's good about a label is that it empowers the consumer to make a more active decision about cybersecurity rather than just being completely helpless as to what the security of her device might be. The average consumer doesn't have a privacy, security, or a legal department to review this stuff before they buy it. Enterprises do, but consumers do not. So someone's got to be looking out for consumers and giving the consumers this information. In addition to informing consumers' purchase behavior, some experts predicted that if the label gets adopted, it could initiate a competition in the market for device manufacturers to enhance their security and privacy practices. An expert said there is value in forcing the company to write a list down, even if the consumer doesn't understand it. If you said, list your open ports, there would be an incentive to make them few. Our experts wanted us to include 47 security and privacy attributes on the label, which is clearly too many to show on a typical product package. Therefore, we decided to design a layered label with 2 layers. The primary layer is this concise format of the label, which could be printed and attached to the package of the smart device. Then there is a QR code and a URL at the bottom that direct consumers to the secondary layer, which has more detailed information and is in an online-only format that can be updated as firmware changes. So this is a dynamic label. Having this online layer is important as devices get updated often. And another important reason to have this online layer is to have a way to accommodate companies updating their security and privacy practices and notifying the users in real time when those practices are updated. To assess our label's usability and information communication, we tested the label with consumers of smart devices. We evaluated the label's risk communication and information comprehension in both non-comparative and comparative purchase process. We started with the non-comparative process. We asked our participants to take a look at the package of the smart device with our label on. We asked them to define the attributes as well as their values. We also asked them to specify the information that conveys risk to them. In the comparative scenarios, participants imagined doing comparison shopping for a smart device from 2 different companies. We asked them to compare the security and privacy labels and specify which company had implemented better security and privacy practices and why. Based on the results, a few of our participants preferred having a single layer label, mostly because of the perceived inconvenience of using their phones or using a QR code scanner to get to the secondary layer. And the second reason was kind of this feeling that the company was hiding some information from them by including it on the secondary layer. However, most of our participants still wanted to have a layered security and privacy label, mainly because a layered label would fit more useful information than a single layer, and they would readily get insight into the information of the primary layer as well as the additional privacy and security practices of the IoT company. As we expected, some of the security and privacy information on the secondary layer was not understandable to all consumer participants. For example, the device's ports and protocols. However, most participants reported that they would still like to see this information on the label to be as informed as possible when purchasing a smart device. One of our participants said, I don't know what TCP and UDP are, but it's interesting to have this here because then I could go to Reddit and ask under what that means and what the capabilities are. Some of our consumer participants reported that our label is useful in informing both consumers as well as experts. A participant mentioned labels are both for customers and experts, such as tech journalists and consumer advocacy groups. If they see something that is questionable, they will raise it in the public press or will raise it with regulatory authorities. The label is not just for the consumer, but there's another feedback process that works through experts. In an iterative process, we applied several wording and design changes, and this is the next version of our label. So until this stage, our focus was to design a label that conveys critical, important security and privacy information in an understandable format to consumers. But in addition to being understandable, we want the label to convey risk to consumers and potentially impact their desire, their willingness to purchase smart home devices. And to assess this, I conducted a large-scale online study, which I will describe next. I surveyed around 1,371 consumers of smart home devices from a crowdsourcing platform. In the survey, I presented several purchase scenarios to participants. Each scenario asked participants to imagine purchasing a smart device with a security and privacy label. And the label talked about only one privacy or security attribute value. This is an example of a scenario that I presented to participants, and the words inside the brackets are the factors that we varied in the scenarios and tested in the study. Imagine you're making a decision to purchase a smart speaker with voice assistant for yourself. This device has a microphone that will listen and respond to your voice commands. The price of the device is within your budget, and the features are all that you would expect from a smart speaker with voice assistant. On the package of the device, there is a label that indicates the following privacy and security practice: purpose of data collection, tailored advertising, and monetization. At the end of each scenario, we ask participants to specify on a Likert scale how each attribute value would change their risk perception, and in the next question, their willingness to purchase and why. I then quantitatively measured the impact of our label's security and privacy factors on consumers' risk perception and their desire to purchase smart devices. For each attribute of the label, we selected two values, which we hypothesized to be the most protective and least protective. For example, for the purpose of data collection, we selecting providing main device functionality as the most protective value and monetization as the least protective value. We hypothesized that the most protective values of attributes should significantly decrease the perceived risk, increase willingness to purchase. We expected the opposite for the least protective values. Then we conducted statistical tests to basically understand how each attribute value of the label would influence risk perception and willingness to purchase. And these statistical models that we constructed showed that consumers perceived a significantly higher risk for smart speaker compared to a smart light bulb. In addition, they were significantly less willing to purchase the smart speaker compared to the light bulb. Our analysis showed that the device recipient had no significant impact on participants' risk perception. And again, in the regression models that we designed, we measured how each attribute value would influence risk perception and willingness to purchase. The results showed that the impact of almost all of the tested security and privacy attribute values on risk perception and willingness to purchase were as we hypothesized, meaning our hypothesized most protective values significantly decreased the perceived risk and increased willingness to purchase, and the least protective values significantly increased risk perception and decreased participants' desire to purchase the smart device. Based on the factor coefficients in the regression models, we ranked the effectiveness of attributes in terms of changing risk perception and willingness to purchase. Starting with the risk perception, the top three attributes that significantly increased the perceived risk where sharing data with third parties, having no control over access and selling data to third parties. On the other end of the spectrum, the top three attributes that significantly decreased the risk perception were having multi-factor authentication, no data sharing, and having no cloud retention. In terms of willingness to purchase, we found very similar trends. The top three factors that significantly increased participants' desire to purchase the smart devices were no device retention, no cloud retention, and no data sharing. And the top three to decrease the willingness to purchase were sharing data with third parties, having no access control, and selling data to third parties. We also noticed a few privacy and security misconceptions. For example, some participants thought that no security updates indicate better security. A participant said, if there are no updates, then the system must be providing maximum security already. Similarly, another consumer mentioned, on the label it advertises that patches are even needed. That is why there is a perception of decreased privacy. So to some of our participants, if you mention that the device receives security updates, that indicates a worse security because the device needs to be updated. That's basically one of the most common misconceptions that we surfaced in this study. Based on the inputs from security and privacy experts and hundreds of smart device consumers, we applied further changes to the content and the design of our label. And this is the most recent version of our label. Now we will talk about the most recent components of this label design journey, which focuses on quantifying the consumer's monetary value of security and privacy protection and transparency for smart home devices. As I mentioned at the beginning, and as we all know, smart device manufacturers are not transparent about their devices' security and privacy practices. Over and over, we see these companies collecting more than promised and needed, and sharing this data with parties that consumers are not informed about. This lack of transparency then creates a vicious cycle where consumers are not able to consider security and privacy in their purchase decision making. In return, manufacturers perceive this consumer's purchase behavior as their lack of care for security and privacy. Therefore, they do not see any value in improving their security and privacy practices and being transparent about them. And this cycle continues. One way to potentially break this cycle and incentivize the device manufacturers to improve their devices' security and privacy practices would be to show that if this information is provided when doing comparison shopping, consumers will value more privacy respecting and protective devices. And one concrete way to measure consumers' perceived value is to calculate how much they are realistically willing to pay for the security and privacy improvements and for security and privacy transparency. To this end, I simulated a comparison shopping setting and designed a large-scale incentive-compatible study to measure the consumer's willingness to pay for various security and privacy improvements. For each label factor, I selected 3 levels: the least protective, medium protective, and high protective. For example, for security update, we selected no update as the least protective value, manual update as a medium protective, and automatic security update as the most protective value. And I did the same for the rest of the label security and privacy attributes. So basically here, the goal was to understand how much each of these hypothesized security and privacy improvements is worth to consumers, how much they are realistically willing to pay to receive each of these security and privacy improvements, going from low protection to medium protection, or low protection to high protection, or medium protection to high protection. So any sort of basically improvement. Okay, so we're not going to talk about the details of the study, but basically the main important part of this work was that we tried to design an incentive compatible study. So we did not just ask people how much are you willing to pay. We tried to measure that based on participants' behavior in the study. We tried to simulate real purchase settings so that the responses that we got from this is closer to the real scenario than a normal study setting. Okay, now let's talk about some exciting findings. I tested 15 security and privacy improvements, but for the sake of time, we're just going to go over the most valuable comparison pairs. For a $60 smart speaker, so the base price of the device, let's say that it's $60, and it's a smart speaker, similar to the ones that are currently on the market. The most valuable practice was having de-identified cloud storage when compared to identifiable one, which was worth a premium of around $13. So $13 on top of the $60 device. The second most valuable improvement was having password authentication compared to no access control. And the third most valuable improvement was having multi-factor authentication compared to having no control over access. So although our participants were willing to pay a significant premium for almost all of the tested security and privacy improvements, there were a few exceptions, and based on the qualitative responses, lack of usability and functionality were the primary reason as to why not all improvements are valuable. For example, we hypothesized that multi-factor authentication provides more protection compared to password access control. So we basically wanted to see participants be willing to pay more to have multi-factor authentication compared to having password. However, our participants were willing to pay significantly more for a device with two-factor or multi-factor authentication compared to the one that comes with password access control. And the main reason for this was basically the lack of convenience and the lack of usability of two-factor authentication or multi-factor authentication. So basically, our participants, despite acknowledging the added protection of 2FA or multi-factor authentication, they found it to be inconvenient and were willing to pay significantly more to purchase a device with password. A participant said, I know the multi-factor is probably more secure, but being able to change the default password is easier. So the kind of the takeaway from this slide is that many consumers do understand the risk of security and privacy practices, but understanding the risk does not automatically translate into people valuing the device which comes with more protective practices, especially if those practices are not in line with convenience or usability, and if they make the use of device less convenient, basically. Another surprise in our study was related to data being collected to provide personalized services and features. So due to the vast amount of personal data that is actually needed to enable such personalization, we hypothesized that consumers would be willing to pay more to ensure that their data is not being used for personalization. However, the results actually showed that consumers are willing to pay a significant premium for having such personalization compared to not having it, even if they kind of find this practice privacy invasive. A consumer said, I like the devices with personalization as they are more useful, but I also know that there's an increased risk associated with personalization, as the device needs to obtain more information about the user specifically. So again, similar to two-factor authentication versus password, people do understand the risk, but that doesn't mean that they are going to pay more for it. They still want a device that is more usable, more useful, more convenient. In addition to quantifying the willingness to pay regarding each individual security or privacy improvement, we also conducted a follow-up study to measure the monetary value of security and privacy label, which presents multiple information about multiple security and privacy factors. We tested 3 versions of the security and privacy label based on its promised level of protection, hypothesized level of protection. A label that indicates most protective security and privacy practice, that's the first version. The second is a label that indicates least protective practices, the second version. And a third one, a label that indicates no transparency. So basically, this label shows not disclosed for all the security and privacy factors. So we tested kind of 3 versions of transparency of label. And again, I'm not going to talk about the details of this study, but again, similar to the first study, we simulated real purchase decision making and we conducted an incentive compatible study. And I'm just going to briefly talk about the results of this work. So the findings showed that, as we expected, providing a label that communicates the most protective levels of factors was most valuable to participants, comparing to having no transparency or a label that signals a risky device. But the finding that was most surprising here was that participants were willing to pay significantly more to purchase a device with absolutely no transparency compared to purchasing a device that was very risky based on its label. So compared to a device that has a label that indicates that all these practices are risky, people are willing to pay significantly more to have no transparency at all. And this finding is not just interesting, but potentially very important because basically that shows that if we don't mandate the security and privacy labels in the US, there might be companies that do not care about security and privacy. And because it's not mandated and because it's kind of a voluntary program, then these companies may decide not to disclose their practices, not to have a label on their products, because they know that people would not value the transparency by itself. They care about a device that has good security and privacy practices. And just having a label that shows a bad practice, they may actually prefer to purchase a different device, even with no transparency. So basically, that means that we need to mandate security and privacy labels to get the effect, to get the kind of the benefit of having such transparency. In addition to the label, we prepared a specification document for consumers and IoT manufacturers. In the specification, we provided a taxonomy for the label, a consumer explanation for each of the attributes, a list of items to include as additional information, and a list of best practices. And for real-world impact, we would like to have our labels adopted. And to ease the process of generating the labels, we developed an interactive tool that allows users to complete a form for different sections of the label and then see the label being generated in real time. In the most current version of the tool, users can download the label in the formats of JSON, XML, and HTML. Users can also work on the label offline and then upload the saved JSON file to resume working on it. To conclude, in a multi-step research-extensive process, I designed a usable and informative security and privacy label for smart home devices. I provided empirical evidence that if the information is readily available to consumers, they would significantly value improved security and privacy practices of smart devices, provided that these practices are still usable and convenient. Our results indicated that to be effective, This transparency should eventually be mandated so that device manufacturers get penalized if they have risky practices. Signed in an executive order, smart devices in the US will very soon come with security and privacy labels. And to get there, I'm having active conversations to inform the key governmental and non governmental stakeholders involved in this program, including the White House, FCC, NIST, CTA, Consumer Technology Association, Consumer Reports, and Atlantic Council. As a next step of this project, I will be looking into designing a security and privacy label for other emerging digital technologies, including AI-enabled social robots and connected medical devices. With that, I would like to conclude my talk and to take a look at our other human-centric security and privacy projects, please visit my Inspire lab at Duke at inspire.cs.duke.edu. And if you're also interested to learn more about the papers that we've written on the security and privacy label, please visit iotsecurityprivacy.org. And with that, I would like to conclude my talk. Thank you very much for your attention.